Hi, good evening, everyone. So, in the last class, we had gone ahead and we had started talking about the two variable optimization. We talked about what is Bayesian matrix. We talked about what is definiteness. And उसमें हमने एक चीज clear की थी that what is positive and negative definite. That is something that we have studied in detail. नाउ टुडे अबाउट सेमी डेफिनाइटनेस उसको हमने इतने अच्छे से डिटेल में नहीं बात की थी सो दैट इज व्हाट my agenda is, and then I will show you the same for three variable case also. So when we talk about semi definiteness, we can have positive semi definiteness, we can have negative semi definiteness, right? Positive semi definiteness homework problem solution was already posted on portal yesterday itself, beta. Positive semi-definiteness is when we have to go ahead and we have to check all principal minors. ठीक है, और नेगेटिव में भी वी हैव टू चेक ऑल प्रिंसिपल माइनर्स. ध्यान से समझना इस बात को, क्या डिफरेंस है. So when we talk about definiteness, definiteness में we were checking only leading principal minors. Only leading principal minors. But suppose कोई definite नहीं है, right? Suppose we go ahead and we find out that there is a matrix जो positive या negative definite नहीं है. तो semi definiteness के लिए I need to check up all principal minors. Now what is the difference? How is a leading principal minor different from any usual principal minor? क्या difference है एक leading principal minor में और किसी भी एक बेसिक यूजुअल प्रिंसिपल माइनर में? व्हाट इज द डिफरेंस? दैट इज व्हाट वी वांट टू हाईलाइट टुडे. ठीक है, सो प्लीज राइट इट डाउन विद मी दैट व्हेन वी टॉक अबाउट प्रिंसिपल माइनर्स, राइट, the difference, key difference is that in principal minors we eliminate same index row and column and check all possible principal minors. Let me give you one example. ध्यान से सीखना. So for example, if I tell you I have a matrix. Matrix is A, B, C, D, E, F, G, H, I. If I ask you what will be its leading principal minors? Leading principal minors. हाँ बेटा, तो leading principal minor will be this A. Then it will be यहीं से, we will start from here only. Determinant of this A, B, D, E. And then we will start from here only and determinant of this. That means determinant of A, B, C, D, E, F, G, H, I. These are called as leading principal minors, right? But when I now talk about principal minors, ठीक है, फिर से I will make this matrix A, B, C, D, E, F, G, H, I. तो प्रिंसिपल माइनर क्या हो गए? फर्स्ट ऑफ ऑल ऑर्डर 1 प्रिंसिपल माइनर्स. जैसे यहाँ पे ऑर्डर वन प्रिंसिपल माइनर क्या था कि सिर्फ दिस फर्स्ट एलिमेंट, दिस ए. अब ऑर्डर वन प्रिंसिपल माइनर विल बी व्हेन यू सी फर्स्ट ऑफ ऑल विल बी ए. एंड हाउ आई हैव टोल्ड यू प्रिंसिपल माइनस कैसे निकलते हैं. यू एलिमिनेट सेम इंडेक्स रो एंड सेम इंडेक्स कॉलम. माने सेकेंड रो सेकेंड कॉलम को अगर हम एलिमिनेट करें तो कौन सा निकलेगा, थर्ड रो थर्ड कॉलम से कौन सा निकलेगा, दैट इज व्हाट वी फाइंड आउट. सो फर्स्ट रो फर्स्ट कॉलम से ये प्रिंसिपल माइनर फर्स्ट ऑर्डर का निकलता है. सेकेंड रो सेकेंड कॉलम से ये प्रिंसिपल माइनर सेकेंड निकलता है. एंड थर्ड रो थर्ड कॉलम से I get the principal minor to be I. So I have to check all possible principal minors. Similarly, now I will go for order 2 principal minors. Second order principal minors. ठीक है, तो यहां पर तो सिर्फ एक ही था. We were only going for this one, right? This, then this, then this. ऐसे ही चल रहे थे ना. So, but now here, first I will take this one, of course. In this, notice मैंने क्या eliminate किया है. I eliminated the third row and third column. So I get the principal minor as A, B, D, E का determinant. But now my question is, if I will eliminate first row and first column, अगर मैं इनको हटा दूं, then what will I get? I will get E, F, H, I. And if I eliminate the third row and third column, then what I will get? I will get A, B, D, E. So I have to go ahead and I have to find all principal minors. Second order के सारे principal minors निकालने. Similarly, third order principal minor, up to I cannot eliminate anything because it will be full determinant itself. So it will be my entire determinant of the matrix. A, B, C, D, E, F, G, H. These are called as principal minors, right? These are called as principal minors. So first row and first column ko you can eliminate. Second row, second column I eliminated. It will be A, C, G, I. Second row and second column. So it will be this. This is first, third row, third column को eliminate करके ये आता है. Then when you will go ahead and eliminate second row, second column, you will get this. Then when you will eliminate first row and first column, you will get this, right? So you will get 3 principal minors of order 2. And then this will be the last one. So what we do is that whenever we talk about semi-definiteness, जब हम इसकी बात करते हैं, we are not checking only leading principal minors. We are checking all principal minors. और positive में क्या चाहिए था? We require all minors to be positive. है ना? So we need that in positive semi-definite, I need that all these should be positive. All these should be positive. All these should be positive. Order 1, very simple beta. Order 1 is nothing but your principal diagonal elements. ऐसे सोच सकते हो. A, E and I. Principal diagonal elements. That's order 1 के elements. Right? So for positive definite, semi-definite, positive semi-definite, what is the property actually? All principal minors greater than equal to 0. Principal minors. I am not talking about leading principal minors only. Nahi. All principal minors. We talk about principal minors as a whole greater than equal to 0. Similarly, when we talk about negative semi-definite, then it should be alternating in sign. माने सारे फर्स्ट ऑर्डर प्रिंसिपल माइनर्स का एक साइन. वी वांट देम ऑल ऑफ देम, राइट? सो वी सेड दैट वी वांट ऑल द फर्स्ट ऑर्डर प्रिंसिपल माइनर्स टू बी व्हाट? नेगेटिव और पॉजिटिव? एनीवन? Absolutely. So we need them to be negative, all of these to be positive, all of these to be negative, right? So matlab what we are saying is, now I am not going to check only one element. I will check all these three, and this for semi-definiteness. That is the difference between definiteness and semi definiteness. So definiteness बोलता है कि सिर्फ लीडिंग चेक करो और काफी रहेगा, बट सेमी डेफिनाइटनेस बोलता है कि सिर्फ लीडिंग चेक करना इज नॉट इनफ, यू हैव टू चेक ऑल principal minors. That is for semi definiteness, right? Now there is another way, to check the property of definiteness. ठीक है, ये सिर्फ याद रख लो एक बारी, दैट इज इनफ. एंड दैट इज दैट फॉर पॉजिटिव डेफिनाइटनेस we need that the eigenvalues of the matrix, it should be all positive. For positive definiteness, we need that the eigenvalue of the matrix should be all positive. अभी मैं एक बार ये सब example में करवाऊंगी. And for negative definiteness, I need that the eigenvalue of matrix should be all negative. Eigenvalue of the matrix should be all negative. ठीक है. Similarly, when I talk about positive semi-definiteness, then it should be greater than equal to 0, eigenvalues. And for negative semi-definiteness, the eigenvalues should be less than equal to 0. This is another way to test positive or negative definiteness and semi-definiteness of the matrix. Let us go ahead. Let us take some examples and things will become clear. Example number 1 for the day. So we need to check for this matrix. And the matrix given to you is 2, 0, 0, 3. Check the what type of matrix this is. Also, write the corresponding quadratic equation for this matrix. Write the corresponding quadratic equation for this matrix. ठीक है, अब देखो ध्यान से समझो. You see that this is a diagonal matrix. सिर्फ diagonal elements है, non diagonal elements तो 0 है. तो हमारे पास एक प्रॉपर्टी आ जाता है that whenever we have a diagonal matrix, for a diagonal matrix, the diagonal elements are its eigenvalues. Are its eigenvalues. ठीक है, आइगन वैल्यू का क्या प्रॉपर्टी था? वी ऑल नो कि determinant of that matrix minus lambda time I should be 0. I will do one more question, इससे clear हो जाए. The lambda that solves this is called as eigenvalue, है ना? That is called as eigenvalue. Now what we are saying? We are saying कि जो भी एक diagonal matrix होता है, मतलब non diagonal elements 0 होते हैं, for that the diagonal elements are its eigenvalue. तो इसका दो ही eigenvalues आ गया, lambda 1 is 2 and lambda 2 is 3. And both of these are greater than 0. So we can say that this is positive definite matrix. This is a positive definite matrix. This can be one method. Method 2, जो हमने last class में किया, you can follow that method also. Check leading principal minors. Check leading principal minors. So what do we get? 2, 0, 0, 3. The first leading principal minor is this 2. And second leading principal minor is what? Determinant of this matrix. That means 6. Both of them are strictly greater than 0. So, positive definite matrix. This is another way. इससे देख लो कि whether it is positive definite or negative definite. Now, let us try to understand how I can write the corresponding quadratic equation for this matrix. बहुत simple है. Any quadratic equation of a matrix is of the form x transpose a x. तो मैट्रिक्स 2 क्रॉस 2 है, माने देयर आर 2 एलिमेंट्स इन द क्वाड्रेटिक इक्वेशन. तो एक x हो सकता है, एक y हो सकता है, या x1 x2 भी you can write. Then it will be 2 0 0 3 and then you will have x and y like this. ठीक है. When you will solve this, जब इसको मल्टीप्लाई करोगे तो 2 into x 2 plus 0 into y 0, तो यहाँ पे you will get 2x. x into 0 0 plus 3 into y, यहाँ पे आपको 3y मिल जाएगा into xy. So when you will multiply, you will get 2x square plus 3y square. 2x square plus 3y square. And we had gone ahead and we had discussed what we had discussed, that whenever you get such a quadratic equation, कल भी हमने डिस्कस किया था, x square तो हमेशा नॉन नेगेटिव होता है, ये भी हमेशा नॉन नेगेटिव होता है. So this is always greater than equal to 0 and it is strictly greater than 0 when x and y are non-zero. That means कि ये हमेशा positive value ही देगा. So we can go ahead and say that when x is non-zero, it will be positive definite. And otherwise greater than equal to 0 तो certain ही है, तो definitely positive semi-definite. And this is the various ways in which you can solve the same question. एक ही question है, आपका जिस तरीके से मन करे you solve that. That is correct. Absolutely. Because this is positive definite. So what kind of function it will be, concave or convex? Convex. So you will get a minimum. That is correct. Right.